Good morning and happy Tuesday. I'm just getting settled in. Wow. Where were we? We have some errors with the context bits. Expected semicolon. One, two, two. Oh, here. Yeah, what's happening here? Wow. Ah, right. This was going to be a transaction, and then this was going away. Fetch database response. What is a fetch database response? That doesn't seem right. Hmm. Okay. Sorry, just getting my drinks ready. Almost there. I think there's just so many changes going on here. I need to reason through this. Test DB sync if there are changes. Has this file changed anywhere else? No. Hey, is Dev? How you doing? How are you? And happy Tuesday. Assert fetch database event. Yeah, this isn't right. This is not right. Let's leave it like this for a moment. Oops. One too many. So in this case, we have an out-of-date client database. And we're trying to apply a range of out-of-date pages to the client. Now, man, the flute in this piece makes it much more, I don't know, light and fluffy than normal. Changed server transaction. Yeah, this should not be a fetch database response. Where else is this used? All over the place. Okay. I have a feeling that changing this was not correct. This should have been kept the same, and then one of the databases, one of the tests down here should have been using that. Oh dear, I've been on mute. Oh, if I'm ever quiet that long, let me know. It would be rare for me to be coding and not talking, at least on my stream. Basically, just we undid a couple pieces that, a couple changes that I made the other day. Now, this is in changed server transaction. I'm going to put this function up above. Hmm. What's going on here? Change server transaction. What we're looking to do here is identify pages that have changed during our mutation process that we can simulate a transaction and send data. And this isn't a SQL transaction. This is a wall log commit transaction in SQLite. Okay. Now first, we calculate checksums for the databases inside of the server temp directory. This is where we're storing our test server DBs. We hash them. Okay, or that's really checksum them. Then we get the one that we're interested in. Same with the client databases. And then we compare page after page, looking for a page that doesn't match. So if the checksums do not match, we don't have to compare the bytes because, well, the checksums represent the bytes. So if they differ, we know there's a change. So at this point, there is a change, and we need to get the data for the change. I suspect that this would actually be faster if we were just comparing the bytes. So up here, we mem out the DBs and just iterate through them, checksumming, doing a bunch of math, which is probably very quick, but still not doing as much as faster. Less code is less code. I don't know. It's an interesting question. Is it more efficient to calculate checksums and then compare the results, or to compare the bytes byte by byte? And does it matter? That's another question. For these tests, I suspect not. And if it is slow, we can always make it faster. I know this pattern is duplicated in here. If we had a get page differences, we could then dry that up and improve it in a single place. See, there's the other one. Essentially, wherever we are doing something like this. Oh, two places. Not so bad. Now, for our transaction, we do need a collection of database pages. We also need the server checksum, the server DB checksum. Those are our pages, updated pages. Transaction ID, say U64. We'll just make it up, really. I guess we could, why don't we use the server DB checksum just for now? In production, it would be different. A question, McColored X. Ask your question. And the commit record. Ah, yes. In my tests, it's just the default. And you are absolutely correct. This is just test code. Um, but you're right. These 4096, we should be looking at page 1 of the database, reading the value from the 138 byte header, whatever the header size is, and then adjusting this. But for this test, I don't think it matters. In production, see, so yes, we absolutely look at the page size values in production, but just not for running the tests. All the tests run with 4096 page size, just so that we can actually change something in multiple pages. Three point 12.0, it became 1000 or 1024. I'm not sure what you mean by it became 1000. Watch your eyes. We're going to a SQLite website. A power of 2 between those two. Good. Since the SQLite database file was designed in 2003, the default page size for new databases has been 1024. Modern hardware, yep. 4K byte page size is faster and better choice. So with 12, it's 4096. Nope, it's all good. All good. Good check, though. Good check. And if we pop over here, while we have everything in blindingly white mode, the page size is, where is it? It's towards the beginning of this file here. So this file change counter here is without wall log. This is what signals to multiple applications using the same database. They look at this to see if anything's changed, and if the file change counter has changed, they basically get rid of their memory caches and use data on disk. And then we have the formats, database page size in bytes. Here we go. Yep. And there are some interesting kind of trade-offs with SQLite. You can only have one writer writing to a database at a time. However, you can have multiple databases, and you can join across multiple databases. So with SQLite, I think that you should regularly, unless you have reason to otherwise, have your database subdivided as well as you can into multiple files. And so plan out your writes and change it accordingly. Yep. It's pretty great as a database. It's all right. Let's head back over to the code, and I'm going to pour some hot tea. Feel a little gravelly this morning. Kind of fighting myself. So if you need transactions across tables, though, there are considerations. Yes. Having multiple database files relieves the contention for the writer. As long as you do not need to have transactions across database files, right? Being able to change many at once in a single transaction. If you do need that, I think you cannot use wall logs for that, but you have to use the other journaling for that. And at that point, it works. But look that up. I'm not as familiar. I just remember reading a couple pages on that. But as long as you do not need transactions across them, I believe just splitting it makes it remove that contention. All right. Oh, same table? Yeah. There would be contention with that. Okay. We have our updated pages. We need a commit record. Oops. Oh, option of a commit record. Hmm. SQLite is much faster than people would expect. Part of it is data locality, right? Round trips. It's in process. When you have caches, it's in process. So at this point, I need to know how many database pages there are. I could probably get that from here. Server checksumdb. It's a ref to a DB. Interesting. This is a dash map. How long have I been working with SQLite? I have never put anything into production. Um, but it's kind of just a little, I don't know, passion thing with it. Really, the most I've done with SQLite is this project. I've kind of played around with it in the past, but with this project, I find myself going through the documentation, going through the source, going through the forums. So I feel I know it okay, right? Not as well as some I know, like a Postgres. But yeah, for this project, I need to know how the wall log works more than anything, and the VFS. Anything that sits on top of that. We know what the size is. You have length. Okay. I thought I did a length. There's no length. What is this? A ref? Path buff DB. Oh, DB doesn't have a length. Ooh. It's called page count. Okay. Good. We need to return the transaction. So we have the transaction. We are going to be using this down here at the end of our tests. We mutate the server database, and this is after having downloaded the database. So everything's in sync up here. We mutate the server, get a transaction, send the database transaction, drop the page stream. That's a bad name. It's a transaction stream, and then shut down and identify, make sure everything's identical. Okay. Crago. There I go. Cragoing again. Cargo test. We want data plane. Okay. So we are testing this functionality here. Stream database updates. Okay. I wrote this a long time ago. I'm not sure if it's correct anymore. Database updates. Okay, it's a transaction. Multiple transactions. We get the file that we need to open. Listen for our shutdown. That tea's good this morning. Database updates. And DB update results. Okay. It looks like we moved all of the logic for this into writing the DB transaction. So we verify the integrity. So validate the checksum of everything before we go to apply it. We create this scope here so that this ref mute doesn't live very long in the function. I know that this is the end of the for loop, but if something changes in the future, our future self might not know this context. So, use parens, validate, then applying the transaction results in a consistent DB state. So if this is the last of a chunk of transaction, before writing the, what do they call that? The commit record. Verify that it's going to be correct in total, and then write the pages. Because if we do this, before we get to this point, we can rewind without the database actually seeing it. Even if SQLite was monitoring the wall log, it wouldn't use this data until that commit record was there. Okay. This looks okay. We have some errors here. These errors are in data archive. Really? One more time. Yes. Oh. Why did that not show up here? It's because it's hard to tell them apart. The path is compressed. Okay. Um, assert stream database update event. Database transaction, mismatch types. This is in our test context. So this is our test server. This is not our test server. Data plane. Okay. Oops. What is this? Somehow I opened something? All right. Not find that. Oh, yes. Well, this is data archive. Let's skip that one. Data archive, data archive, data plane. And the last one, also data plane. Okay. Good. Test again. Ooh, look at that. 7 tests passed. Yes. Ooh, happy day. Okay. Let's get the data archive doing the same thing. What do we have here? Mutate database and stream changes. Where is this used? So we're in replicate, in a test stream database updates, test stream database updates, happy path. Okay. Stream database updates. That's from Prost. So this endpoint here. We start with 3 DB tests, or test DBs, in a context object. We're using happy DB. We download the pages, and now we get the database checksum. So mutate the DB and stream the changes now that the client has the DB in sync. So the database was out of sync. Now it's in sync. We will change it and stream the changes. So we get a starting checksum. We start listening to the stream. Got it. Mutate the database and stream changes. Why are we doing 2 of these? This mutates the database. Yes. This one doesn't need to be mutated. Okay. Let's move that comment up. That goes away. We'll get an end checksum. We assert that the beginning and end changes to the database are not equal, asserting that there are changes. Now we need to stream those changes from our stream response into the database. Well, in theory, what are we looking for? We're looking to see that data flows through the server. So unfortunately, we have to apply the changes. Ensure that the page data is correct. Okay. This is commented out. Page data response. Is that what we have here? We have a database page. That is surprising me. We have data here and here. We deconstruct it into something else. Streaming database page. This seems silly. Why are we doing this here? Feels like we should have some function like tc dot apply database update stream to something like that. We just apply it, and then we check to see if they're the same, if the databases are identical. Hmm. Do we do it that way, or do we ensure that the data that comes through is correct? Now, in this case, we do not have a server and client, right? This is just testing the server. So we're not able to compare it versus the client database. Hmm. So what do we test here? That the database at the end of applying this has the same checksum? Maybe. Or do we just check to see that we've received changes? The big question of how to test this. I'm going to think on this for a minute. What are we trying to test? We're trying to test that streaming through the system works. So, as a change comes in, we want to see that the change is identical on the other side. Like, this is kind of a boring test. This is just so that we can send it through Iggy. Hmm. All right. We're testing that we don't have to-dos in the in the code. Yeah, there's a lot going on here. So we're taking the gRPC transaction and returning a future. Okay. So we get the raw stream for that. So essentially what we're testing is that is the code between here and the send at the end. All right, we want this stream of data to exercise this flow of code all the way down to here, and errors if we need. So we want to see database transactions come out. So we need to know what's getting sent in. See what, where's Piggy? Is it still in the stream? Oh, it is. Let's extract that. It should be its own module now. There it is. All this does is return this stream, a stream of received message. That's right. Okay. So in the test, we generate received messages, a stream of received messages, and we get back transactions in order to make the database up to date. Okay. So we set the raw stream. That's how we plug into Piggy. Now find struct variant. Okay. Do we need that? So we're creating the stream for Piggy. We need headers. Here's our pulled message, received message. And we stream that. Okay. Ah, that's right, though. MuteTB and stream changes. So in this case, we change the database. We just make some changes. Seems rather complete. Okay. Okay. Lost my place. In this case, it feels like, let's see, NDB streams. Okay. What? Dog's barking. That's not me barking, by the way. It's not me. So we want to send a polled message. Is that really what we want? Yeah, I could see that. And we want to send a polled message based on the difference in the chunks of the database. So we make a backup. Got it. So we have a backup of the database so that we can tell what pages have changed. Or which pages have changed. Oh, I see. Okay. So in order to create these here, we have to serialize a transaction, a DB transaction. And all of the pages, all of the different pages would be part of that transaction. So I do not think we need this information in there. We're not adding headers at this point. We're simply collecting a series of database pages here. Let mutable pages equals back. Do we know how many pages changed yet? No. So all of this goes away. Maybe. I'm just going to comment it for now. Okay. I think that we're actually going to need that just after the for loop. I like this song. So we have the page data, the backed up page data. This is the original. Actually, we could. Hmm. We could do a filter map and just do this comparison in the iterator. Page data, backup page data. So at this point, we want to add the database page to the list of pages. Database, no, it should be database page. A database transaction takes a collection of database page. Database page. Go figure. It's not your fault, Rust. It's all me. It's okay. We'll start constructing the database page. Comment that out or get rid of it. Okay. So we have our transaction. We have, what do we have here? Let's add the structs. Good. We have pages, transaction ID. Does it really matter? Maybe it should differ. We could get the checksum of the DB itself. Why is transaction ID a U64? It is the, oh, I should have written that down. Salt of the database. Let's update that real quick. No, checksum 1 and 2. Okay. Future me will appreciate that. Okay. Commit record. Hmm. And the page count. How many pages are in the database after the mutation? This is something that I don't think I've handled perfectly throughout this. I'll have to do some tests on deletion. Oh, this color scheme is called Challenger Deep. How many pages are there? It would be dB bytes divided by that. Or just how many chunks there are. Checksum. Checksum of this data. Interesting. I don't think I have the checksum. What are we doing with this? We just get the checksum out of it. We're not keeping it up to date. Hmm. Hey, Togglebit, how you doing? Oh, thank you. And Fez, I'm not sure how to pronounce your name. Thank you for the comment. Let's see, this should be a U32. Oh, expected U size. Oh, my mistake. Expected U30. Wait. I thought. All right, database page. It should be a U32. Yes. Oh, but page number is a U32. Pardon, it's a U size because it's from one of these iterators. From enumerate, that's going to be a U32. Oh my goodness, I keep saying these things wrong. It's going to be a U size. You can kind of tell what I'm looking at when I speak because I'll say those words instead of the words that I mean. We need to check some for that data. I feel like I should have kept this DB up to date, this checksum DB. Let's do that. Where's the page thing? Page count. Checksum, that's not it. Page checksum. Set page checksum. That's not quite it. We want to tell it the page number and the data and have it do the checksum. Looks like I don't have that though. Really? Okay, struct db. Oh, because it's %n db. Hmm. Lots of things have db in their name. Not those. Resize, not that. Hmm. Interesting. Set page checksum. You have to checksum it outside and tell it? Okay, but I want to just do that and have the data. Calls this. Okay, a bunch of tests. Great. And where we are checksumming the whole file. Fine. Data plane. Actual page checksum. Huh. We checksum the data and then pass it in. Oh, because we want to ensure that it's correct before we mutate it. Okay, fine. Back here. Let's say checksum. So we get the checksum. We need to update our DB with it. And this is SQLite in your one-based page numbering. Is this one-based here, or is it not? Ah. This is expected to be zero-based. See, I've been slowly adding this. What else? We need the page number. We have checksum is just checksum. And the data. Oh, I see. We need to own that data. We will into iter on that. I still found a reference. Why is that a reference? Is that a reference because of chunks? Hmm. I suspect it's chunks. So otherwise, if this had been, well, it's yeah, chunks over a large vector. So we need to take those portions and do something like that. Hmm. No into vec. To vec? There it is. Into means that the ownership is changing. To is more of a potentially costly conversion, as is a lightweight conversion. Not borrow data as mutable. Really? I just mark it as mutable? Ah, get db mute. Okay. Great. Now we have to make it mutable. And it's mutable. Okay. What do we do with the stream portion? Oh, we have to send the data. It's just down at the bottom. We haven't sent it yet. I moved here. I guess we could keep a count. Hmm. Or before we do anything with it, and let's extract this out to some value. Okay. Type info. Actually, we could say, oops, wrong side. I'm going to pour some tea. Just a moment. All right. page count. Good. So then we have our page count. And that's here. Oh, let's just call it DB page count. All right. That's clean. Now we have our transaction. At that point, we need to send it. Oh, expected received message found. Database transaction. Oh, of course, yes. There's more. Hey, good morning, Mars. How are you? We need some sort of received message. It'd be better if you could figure out how to fix stupid. It's worth noting that, you know, you married them, you can't fix them. They are who they are. Presume you're talking about somebody significant in your life. It's all a joke. I just. Nope, just customers. All right. So, still somebody in your life. We're going to start at the bottom here and work our way up. So, our received message. It's the message, a current offset, which we don't really have one at the moment. And this would be the location in the Iggy log. And because this is a fake implementation, we don't know where it is. So we could make something up here. I would never as well. I would never. All right, current offset. Current offset. Let's just set that. I'm going to just set it to 1. Why not? Transaction ID. What do we need the checksum for? I don't think we need that. We no longer need page number as a header. Ooh, that might be interesting. And DB checksum at the end of this is actually going to be inside of the checksum value. Goodness, do we not need headers at all? Oh, lovely. Okay, I'm liking this better. So this could just be none. Payload, that is DB transaction. It's going to be something like that, like into bytes, as bytes, something like that. Checksum is DB checksum. Okay. Oh, this is it. Wait. Okay, so this is a type inside of here. It's a prost message. And a prost message, I thought these types had serialization on them by default, right? They're gRPC messages. So we can encode to vec. Okay. That's odd. Shouldn't it be there? Dang, did that get disabled? No, it's there. Okay. It has serialize and deserialize. Hmm. Oh, but we need our data. So pulled message is fine. This is really about database transaction, and database transaction. It's not controlled by us. This is derived. Let's look at our generation. Let's see, read directory, collect. Tonic build. Hey, Mindstormer. How you doing? Thank you for the raid. Okay. Enable the process generator. Why, why do we not have enabled by default? Okay. It's going pretty well. Going pretty well. I'm struggling at the moment with this object. Or is it commit one back? Database transaction. I need to convert it into some, well, I need to serialize it into a vector. This is generated by Prost and was it tonic build? Hey, Godwow. How you doing? Right, so we have a config. Is there anything we should have in here? Disable comments. No, we want comments. Format. I feel like I'm missing something during the compilation step. Hey, Yash Saxona. How are you? Include file, generate, extern, disable comment. Bytes. Oh, here we go. Configure the code generated to generate Rust bytes fields for protobuf bytes. That's not the same. I want it to be able to get serialized to bytes, not necessarily support bytes itself. Although using bytes for bytes, that's a good change. I'm glad we saw that. Let's enable that and break a bunch of things as we're at it. Why does that want paths? That's directly, okay. Previous configured paths for bytes will be cleared. All right. Not sure. I'll come back to that at the moment. Oh, a specific field. Oh, goodness. Yeah, let's just do all of them. Okay. I thought it was a file system path. Oh, so curious on my opinion of AI code writing assistants. For if you go back in my stream archive, you'll see that I was using was it Zed? Because Zed has decent support for AI code writing. And it was okay. But I found it as like it was very disruptive to my workflow. I found that I produced worse code because it kept pulling me out of my coding headspace. Like somebody coming up and saying, "How about this code? What do you think about this?" And I would have to analyze it, stop, forget about what I was doing somewhat, right? Is this code acceptable? Is it doing what I want? Right? So it pulled me out of my zone. So I've actually gone away from Zed and Copilot and the other ones that I tried just because it was such an interruption. Like I could see using it when I call on it, but I don't want it constantly there. Oh, you're playing around with cursor. I think I tried that one too. Hey, Clearmio. How are you? Okay, but still we don't know how to get this as bytes. Which broadcast, wait, what is it, protocol am I using in which order of events do I choose for my system? For the distribution of the SQLite data, is that what we're talking about? What's the context? Are we talking about like streaming, like my OBS setup, or I think we're talking about the the system I'm building. Yes. Helix versus NeoVim. I like NeoVim, but I don't like configuring it. I want something that just works well enough that I can get good at. I didn't find it that way. So I'm in Helix. That's fine. Well, protos, well known types. Yeah, I think I've done everything here. I want to look at Prost again. Uses the bytes buff abstraction for serialization instead of standard IO read write. How do we get access to this? Yeah. All right. So we have bytes. Let's pull this into that file. Hmm. Oh, this was on a specific trait. Hold on, that was in Frost message. So let's just import this. Expected bytes, found vector. Interesting. Oh, that just changed, didn't it? Yeah, this is not what I want. I want encode to vec. Hey, Dojo Drummer. Does sqlite have either the decimal or numeric type? Um, their types are rather flexible. Let's check real quick. Watch your eyes. They have integer and real. So if you need a floating point value, use real, otherwise integer. Yep. Direct message, debug, send and sync, provided message. See, it's this one that I'm trying to get a hold of. Encode to vec. All right, I gotta make a different note real quick. Uh, Give me a sec. All right. Can a comment be a link to a URL? Um, a comment like in source code? Yeah, you could have a link to a URL in source. I think I do that when I'm referencing external systems. Okay. Hammer dulcimer? It sounds like it, doesn't it? Okay, so this isn't doing anything. Oh, undeclared module, pros. Oh, I don't even think we have it here. Oh, we do. Good. Type mismatch. Expects bytes. Encode to. Okay, so we need to encode that to bytes instead. So we can create a bytes object, encode into it. Okay. So let's have that. Where is it? DB transaction. So we have a bytes mute. Bytes mute. Oh, I need to import that. Okay. code, and we give it the mutable reference to DB transaction bytes. Then we have DB transaction bytes, which we can give here. Mismatch types. Oh. Bytes. What returns a bytes? A new bytes, default bytes, from bytes. Ah, freeze. So we'd freeze a bytes mute. Okay. There we go. Nice. Yep. Now this is going to need to be bytes, etc., because we're converting everything to bytes. All right. All right. Oh, that's a slice. Do they have a conversion? They do. Nice. All right. I have to get going, but thank you all for hanging out today. I'll probably clean up some of these bytes bits tonight. Do a quick pass of that after work so we can get on to some more interesting bits. Let's go ahead and raid someone. Who should we raid? Hmm. Rusting good dough? Alright. Hmm. We're gonna try it. I don't think I've ever raided anybody with an like a avatar person. Alkaline VT. Alright. It does look like Rust. Alright. I used to do video encoding, and I can see that they have snowflakes or something on their stream. That is brutal on an encoder. Watch any parade where they suddenly toss out like a bunch of confetti or TV broadcast, anything. And encoders don't handle that well. Anyhow, thank you all. Until next time. Bye bye.